Okay, so we're practicing graphing cosine today. Okay, so again, the first thing I'm going to do is I'm going to graph my parent function, but I'm going to write this equation with its transformations. A cosine bx minus h. Okay, so this basically will show me what each of these transformations refer to. So k, that is our vertical shift, which means my center line is at y equals -2. A, this is my amplitude, which is 2. B right here, and you can't really see it, but if I rewrite this as 2/3 times x like that, you see that my b is 2/3. So we use the period equation, which is 2 pi over b. So we get 2 pi over 2/3, which means that this is the same thing as 2 pi times 3 over 2, which means my new period is 3 pi. And again, we don't have a horizontal shift. We do have a horizontal stretch, but not a horizontal shift. So let's start by drawing the parent function for cosine. These are the 5 key points. They're the quadrantiles where the unit circle hits the x and y axis. Okay. So I always tell my students to start with order of operations, so the transformations that multiply. So that's your stretches and compressions. So for this one, the hardest part is going to be the horizontal stretch we have to deal with. So that's what I'm going to do first. So I know my function is going to start right here, but now my wave is 3 pi long. So that means that this point is now at 3 pi. So it starts at 0, ends at 3 pi. Now, you could sit here and multiply each one of these numbers by 3/2, but that's going to take you a while. So another way of thinking about it is, since there's symmetry in the circle, there's also symmetry in the wave. So for instance, in the original, notice how it begins and ends at its maximum. Right in the middle is its minimum. So same thing, in our stretched one, halfway between here and here is going to be where our minimum is, which is right here at 3 pi over 2. Okay, and then the same thing, halfway between 3 pi over 2 and 0, that's where this 0 should be. Which would be right there. And right there. So here is my horizontally stretched cosine. Next, I'm going to do so this is this part, the blue one is that part. Next, I'm going to do my amplitude change. So that's my vertical stretch. So my maximums and minimums are now going to be 2 away from my center line. So 2, this still is at 0, this will be at -2, 0, and this is 2. So here is my vertical stretch by a factor of 2. And then the last thing we need to do is change my center line or my vertical shift, because my center line is now going to be at -2 right here. That's my new center line. Okay, but basically it was at 0, so everything shifts down 2. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So here is my fully transformed function. And I always draw my fully transformed function in red, so this way my students know exactly what my last, or the answer is supposed to look like. Okay, black I always use for parent functions, and red I always use for my ending function. Okay, and of course we need to double check. So one way of double checking is, well, this is my center line. my amplitude is 2, so my maximums and minimums should be at 0 and -4. Are they? Are my zeros still on my center line? Absolutely. And if I wanted to, I could pick a point. So, for instance, I could say, okay, let's see, what would be easy? Let's do 3 pi over 2. So if we plug in 3 pi over 2, we get -2 plus 2 cosine of 2/3 times 3 pi over 2. Okay? So 2 divides out with 2, 3 divides out with 3, so you get -2 plus 2 cosine of pi. Well, what's cosine of pi? That's -1. So we got -2 plus 2 times -1, which means -4. So I should have the coordinate 3 pi over 2, comma, -4. Is that where I ended up? Well, here's 3 pi over 2, and it's at -4. So that's my coordinate. So 9 times out of 10, if that one that you check is correct, then the rest should be correct as well.